Serial interface or UART has been a popular interface for connecting many peripherals such as keyboard, mouse, modem and printer to your PC. It had three major drawbacks: low speed, complex cabling and limited number of ports on computer. Universal Serial Bus or USB as it is popularly known has broken down all of the above and provided a very robust, reliable, inexpensive and convenient standard for connecting various peripherals and devices. We will now discuss non-technical details of USB first. History of USB. USB was promoted by Compaq, Microsoft, National Semiconductor and 25 member companies which created first standard in 1996. It was intended to find a common interface to replace serial, parallel and game ports with a single connection which will seamlessly and interchangeably connect various diverse peripherals such as keyboard, mouse, printer, CD-ROM drives and others. They created a trident logo which is printed on plugs of all USB devices and is shown in figure 1. Unlike serial port which was a point-to-point connection, USB works as a bus connecting many devices to PC through a single port. Second advantage it offered was providing 5-volt supply to devices connected to it. That made devices much more portable and swappable. The third advantage was hot pluggability. The fourth advantage was that software needed to communicate with device was made the responsibility of the PC and simplified the device's task. That helped devices to be simpler and cheaper. We will discuss these further in later sections. Following table gives a brief history of USB standards and their years with salient characteristics. It is clear from the table that the standard has evolved significantly from modest speed of 1.5 megabits per second to 10,000 megabits per second in over a period of about 20 years. Now, USB is capable of fastest data transfers possible on modern computers and is on par with other superfast interfaces like Ethernet network adapter. Types of USB functions and classes. A USB device can provide a large variety of services. It could actually generate data as in keyboard and mouse or one which absorbs data as in printer. It could also be a third type which stores data as in pen drive or which communicate data in some other form Wi-Fi. A physical USB device may consist of several logical subdevices that are referred to as device functions. A single device may provide several functions. For example, a webcam video device function with a built-in microphone audio device function. Such a device is called a composite device. Second type of device is called a compound device, in which the host assigns each logical device a distinctive address and all logical devices connected to a built-in hub that connects to the physical USB cable. The functionality of USB devices is defined by class codes. Each device communicates this code to host PC so that it recognizes whether the device is a pen drive or a printer or a mouse and so on. Some of the device classes are given in table 1, which is self-explanatory. The list is quite long and the class number goes up to 255. USB features. USB is best characterized by following features and attributes. 1. Multiple devices. Up to 127 devices can be connected on a single bus. 2. Transfer rate from 1.5 to 5000 megabits per second. 3. Versatile, supports more than 20 different types of peripherals. 4. Hot pluggability. A USB device can be attached or detached from a PC when PC power is on. 5. Plug and play. The PC OS recognizes the device plugged in, its function, and appropriately activates its device driver software to talk to it. Similarly, it detects device removal and unloads the driver. 6. Ease of installation. Only one type of standard cable and connector and allowing any plug to go in any socket. 7. Hub architecture. Each device is connected to a USB hub. A hub is an intelligent device which connects to PC on one side and to many devices on other side. It is multi-tiered topology, that is, main hub can drive many lower level hubs which in turn drives many devices. This allows signals to be regenerated inside each hub and high speed of communication is sustained over longer cables. Figure 2 shows one example of a setup showing PC as a root hub followed by several hubs and devices. 8. Host centric. The CPU or PC initiates every transaction with every device. This simplifies device software, but as the number of devices increases, it increases burden on PC. 9. Power allocation. PC supplies power to devices. The current drawn by devices is monitored and attachment and detachment detected. When a USB device is first connected to a USB host, the USB device enumeration process is started. The enumeration starts by sending a reset signal to the USB device. The data rate of the USB device is determined during the reset signaling. After reset, the USB device's information is read by the host and the device is assigned a unique 7-bit address. If the device is supported by the host, the device drivers needed for communicating with the device are loaded and the device is set to a configured state. If the USB host is restarted, the enumeration process is repeated for all connected devices. Terminology used in USB standard. Let us understand more about the details of this interface by looking at some standard terms defined. Host. Usually the PC or laptop or tablet which runs an OS and which has device drivers to connect to a wide variety of peripherals driven on USB. This is master of USB bus and controls and schedules all communication activities. Hub. This is like a switch which connects multiple devices to a single USB port of PC. This is a smart device and supports plug and play. It remembers which device is connected to which port and routes traffic to it. The port connected to PC is called as upstream port. The port connected to a device is called as downstream port. There always exists one hub known as the root hub, which is built in the host controller. Device. This is a peripheral having an embedded device and a special IC which connects to the USB bus as a device. This is a slave on USB bus. Peripherals or devices controlled by USB are slaves responding to commands from the host. On the go OTG. Initially on USB bus, there was a PC as master and the devices as slaves. However, there were a few units which behave like a slave mostly, but occasionally may have to work like a host. Normally, a camera will be a device to a PC, but it may become a host to a printer or a TV to print or show stored pictures. The OTG protocol provides an arbitration mechanism that allows units to negotiate who is going to be host. OTG introduces an additional data pin ID that determines the initial status for the host device negotiation. OTG products may also be known as dual role devices. Function. A USB function is a service or an activity which a device provides to PC. The function could be keyboard, mouse, printer, plotter, scanner, etc., etc. A physical USB device may consist of several logical sub-devices that are referred to as device functions. One device may have two or more functions possible, such as a multifunction device may have a printer and a scanner and a fax machine, all operating out of a single USB cable. Endpoint. USB physically connects PC at one end and device at the other end. One end of the logical connection in this is a PC's operating system. The other end of logical connection, which terminates inside a device, is called as endpoint. The endpoint is a source or destination of data being exchanged with PC. Each endpoint in a device creates a unique logical connection with OS. Pipe. Inside PC, device driver software provides services to transport data over shared wire. This driver offers a delivery service providing a channel called pipe which carries data to various functions in a device. Pipe routes data sent by OS to various functions inside a single device. It is a logical entity. Message pipes are bidirectional and are used for control purposes. Stream pipes carry data in one direction. A USB device can have 16 pipes coming into its host controller and 16 going out of the controller. Conceptually, a host controller, that is a PC connected to a device by a single cable. Internally, it appears that there are three logical endpoints performing three different services or functions, each working with PC on its own logical pipe. In this section, we will discuss hardware, protocol and software details of USB. Connectors. All devices have an upstream connection to the host and all hosts have a downstream connection to the device. There are commonly two types of connectors called type A and type B, which are shown below in figure 4. Type A plugs always face upstream. Type A sockets will typically find themselves on host and hubs such as computer main boards and hubs. Type B plugs are always connected downstream and are found on devices such as printers. Figure 5 shows a standard USB cable to connect a PC to printer having type A and type B plugs at both ends. Following figure 6 shows the pins and the signals on USB connector. As shown, it contains two power wires for 5 volt and ground. It contains two data lines shown as differential signals D plus and D minus. USB also supports some more types of connectors which are smaller in size for use in phones and tablets. They are shown with a centimeter ruler in figure 7. A variety of 6 USB connectors are shown from left to right: male micro USB B type, USB 1.1 micro, male mini USB 5 pin B type, female A type, male A type, male B type. USB signals and coding. USB signals are transmitted using differential signaling on a twisted pair data cable. Differential signaling means that to transmit data as 1, D plus is made more positive than D minus. Similarly, to transmit as 0, D minus is made more positive than D plus. This cancels out common noise on both wires and gives higher reliability than serial interface. Some more details are: Low and full speed modes USB 1.x use half duplex method. Transmitted signals are 0 to 300 millivolt for logic low and 2.8 to 3.6 volts for logic high level. High speed mode USB 2.0 uses the same wire pair but with different electrical conventions. It uses lower signal voltages of 0 to 10 millivolt for logic low and 360 to 440 millivolt for logic high level. Super speed USB 3.0 adds 2 additional pairs of shielded twisted wire dedicated to full duplex super speed operation. USB system uses a combination of NRZI and bit stuffing technique to encode bits sent across the wire. NRZI means non-return to 0 inverted. Figure 8 shows data pattern and resulting NRZI coding. Note that whenever the data is logic 1, the encoded waveform level remains constant. Whenever the data is 0, the level is flipped or inverted, that is 0 becomes 1 and 1 becomes 0. Thus, zeros in data cause transitions in encoded waveform which help receiver clock to synchronize with the transmitter clock timing. However, if there are a number of ones in data stream, then the waveform will not have any transitions and receiver clock will drift away from transmitter clock. The standard dictates that not more than 6 ones will be sent on wire. If there are 7 consecutive 1 bits received, then it is an error. To take care of this anomaly, the transmitter hardware detects 6 consecutive ones and after that inserts a 0 deliberately to introduce a transition. At receiving end, receiver detects 6 ones and removes following 0, which makes it normal data. Figure 8 shows insertion of a single 0 after 6 ones. Packets and transfers. USB has 4 different packet types. They are: 1. Token. These indicate the type of transaction that would follow. 2. Data. These carry actual data. 3. Handshake. These indicate acknowledgement for received data or an error. 4. Start of frame. These show beginning of a new frame. A packet consists of different fields having 1 or more bytes. For example, the data packet format is shown in figure 9. Sync field contains 8 bits followed by 8-bit packet identifier or number PID. This is followed by up to 1032 bytes of data. The packet is terminated by 2 bytes CRC error detection code and end of packet byte EOP. USB supports 4 types of endpoints or data transfer types as follows: 1. Control transfers, 2. Interrupt transfers, 3. Isochronous transfers, and 4. Bulk transfers. Control transfers are typically used for command and status operations. They are essential to set up a USB device. Their packet length in low speed devices must be 8 bytes and may be longer in higher speed devices. Interrupt control transfers are requested by devices and are queued. Host polls all such requests and carries out data transfer one by one. These transfers guarantee a certain speed and response time. Isochronous transfers occur continuously and periodically. They typically contain time sensitive information such as an audio or video stream. If there is an error or delay in a voice or picture packet, then it is not retransmitted but simply dropped, as it is less likely to be noticed by human listener at the receiving end. Bulk transfers are used for large bursty data such as a large print job sent to printer or an image generated from a scanner. Bulk transfers provide error correction in the form of a CRC16 field on the data payload and error detection retransmission mechanisms, ensuring that data is transmitted and received without error. Bulk transfers are lower priority job which use spare unallocated bandwidth on the bus. They are done after all other transactions have been completed. If the bus is busy with isochronous and or interrupt, then bulk data may slowly trickle over the bus. Hence, they are used where information is not affected by delay in transmission. In coming years, Type C USB is going to be very popular and commonly used. Developed at roughly the same time as the USB 3.1 specification, but distinct from it, Type C specification 1.0 defines a small reversible plug connector for USB devices. It is common both for host and the devices and mean to be future proof. It has 24 pin double sided connector similar to micro B connector and of size 8.4 mm by 2.6 mm, providing for following connections: 1. 4 power ground pairs, 2. 2 differential pairs for USB 2.0 data bus, 3. 4 pairs for high speed data bus, 4. 2 sideband use pins, and 5. 2 configuration pins for cable orientation detection and others. Full featured USB Type C cables are active, electronically marked cables that contain a chip with an ID function based on data channel and vendor defined messages. USB Type C devices can deliver 900 milliampere current from power. Devices can draw higher current up to 1.5 or 3 ampere after negotiations with host.